Okay, this is a fraction tool and I'm going to make some fractions. I'm going to make automatic ones. They're going to tell me here which ones to make and we're going to make them. Each of these shapes is always 1, so that represents one whole or one unit, the number 1. It's asking me to make the fraction 1/2 or 1 out of 2. I'm going to use this division here to divide my fraction into 2 equal sized bits, so I make sure I've got the same number of ticks here, 1, 2, 3, 4 spaces here and 4 on top, so that divides it equally in half. Okay, and I need to select the part. So if I select that black part there, then I'm showing 1 out of 2. Just check. Correct. Select another shape to show the next fraction. So I'm going to go to circle. They want 1/7, so I'm going to get my divisors or my knife out so I can cut them up. Just put this one out the way and start making some cuts. Now I think I've got enough cuts in there. I'll just count from here, 1, 2, 3, 4, 5, 6, 7, perfect. Now the trick to this is that the pieces are meant to be evenly sized, otherwise they're not sevenths, they're all different sized fractional pieces. So it has to be 1/7 of 1, which means we have one whole and we're cutting it up into 7 pieces. So each of them is 1/7. So this program's clever because it gives me the right number of divisions around the circle that helps me to divide it into 7 equal parts. So I'm going to choose gaps of 3 to start with. And I pull this one, make this one a wee bit bigger. 3 there, 3 there. Every one of those 7 pieces is 3 ticks wide, which is perfect to me because they're all the same size and there's 7 of them. So I managed to divide that up properly. 7 threes, 3 spaces each is 21. So the program would have given me 21 ticks because 21 is a factor. A multiple of 7. Alright, 21 is a multiple of 7, or 7 is a factor of 21, and so 21 spaces was okay for me to be able to use each of those 3 to divide it up equally. So let's just check my divisions, my cuts. Well done. Select the number of parts to show the fraction. Well, I only need to show one part, so that there is my 1/7 sized piece. That's what a 7th looks like. Let's just check it. Correct. Now another shape. Let's go back to our friend the square. It wants 9/11, so let's put the divisors or the divisions on there. I need 11 equal size pieces, so let's try for spaces of 2 little divisions of 2 in between each cut. Another cut. I count up so far 1, 2, 3, 4, 5 sections, 5 slithers. I think that's around almost halfway, not quite, which is a good sign because 5 is less than halfway to 11 and 6 is just more than halfway, and that division there looks like it's more than halfway down this square. So I think divisions of 2 are good. It's probably given me 22 spaces to work with here, which is cool. So I could divide it up equally. Count off 1, 2, 3, 4, 5, 8, 9, 10, 11 equal sized pieces. Click. It wants 9/11, so we need to select 9 of those 11ths. 3, 4, 5, 6, 7, 8, 9. So the black amount, the black area or the black portion is 9/11 of the way onto 1. Alright, we are 9/11 of the way from 0 to 1, 1 being the whole. Let's just check that we've done that correct. Yes, it likes that. Circle time, 5/12. Put the divisions out and we want 12 pieces. This time I'm going to do it a little bit differently. I'm first going to divide my circle up into thirds. So I'm going to use my eye to make pieces that are a third big. $16 there. $16 to there. Perfect. So there's 16 ticks on each one, and now what I'm going to do is I'm going to split each third into half. So I'm going to go 8 ticks around between each third. 1, 2, 3, 4, 5, 6, 7, 8 I think is here. Doesn't look right. I think it must be there, and I'll just count this side. 2, 3, 4, 5, 6, 7, 8. Perfect. One more over here into 8. I think that's right. A quick count. 2, 4, 6, 8 sections there. And so where I had thirds before, I'm dividing each third in half. So I've actually only got 6. I want 12ths because my denominator is 12, so I want 12 equally sized bits. So guess what? I'm going to, now here's my 6 bits. You can count them up if you like. 4 ticks in between will give me a half of a 6th there. So this one's been halved. Next door's halved. Next door section, which was 6 big, is halved. 4 gaps in each. Four gaps there. There. So making fractions is actually quite difficult. It's actually quite a fussy job. I should have 12 equal sized bits there. If I look at my halfway line between this one and this one, I'll count 6 on each side. 1, 2, 3, 4, 5, 6. I'll check by eye that each division is 4 ticks or 4 sections of this clock the way around. 1, 2, 3, 4, 5, 6. So it looks correct to me and all evenly balanced. So those 12 pieces are the same size. So I'll check that. Okay, so that's my bottom part. I want 5 twelfths. Now each of these pieces is 1 12th. So to choose 5 twelfths, what I'm going to do is choose randomly 3 there. That's 3 twelfths, 4, 5 twelfths. So they don't have to be next door to each other or in any pattern. I just need to choose 5 pieces out of 12. And I'll check that. Yes, correct. And let's do next shape. It wants 2/6 of that, so I'm going to use my divisors to do sixths. Now I can chop this side here into 6 equal pieces, which will give me sixths. And I think 2 bits each should do it for me. See how halfway I'm up to halfway, and I've got 3 bits, and the other half can have 3 equal size bits, which gives me 6 altogether. So those slithers there are 1/6 each of them, and I can choose 2. I'm not going to do that. I'm going to ditch the middle guts ones and have thirds at the moment. Let's make them even, and then they will be thirds. Bring this guy down. Okay, so they are evenly spaced with 3 spaces inside each one. One is actually 4 bits there. Alright, so it's not working for me too well, what I'm trying to do. I want a third, so I need to get rid of a cut and have 3 equal size pieces with 4 in each. Four divisions, and now they're thirds, so that's beautiful, but I want 6. Before I had some these thirds cut up in half again to make 6, but I'm going to do it differently this time. I'm going to half each third this way so that those 6 bits are still the same size, but I've done horizontal cuts and then a vertical cut. So instead of long skinnies, I've done rectangles this way. 2 by 3. 2 3s are 6. 6 equal size bits in one. Okay, Now it wants 2 bits out of 6, so I'm going to choose these guys next door to each other and check it. And that's equivalent to 1 part out of 3. So where we had thirds before, 1/3, 2/3 across 3/3, this is 1 out of 3 bits this way. Okay, let's do the next shape. 4/12 is what it wants. So we're going to have radial cuts, 12 bits. There's 6 bits. If they were the correct size, it should be taking up half this circle, because if I want 12 even size pieces, 12ths, then 6 of them should take up half the circle, and it's not. So I need to make the sections bigger than I had them. So instead of 3 spaces, I'm going to try 4 to see what it feels like. That feels better. One, two, three, 4. Getting a bit cross-eyed doing this. Okay. There's a line opposite of each of these lines here, so the cuts go through. That means that on this half I should have 6 pieces. 1, 2, 3, 4, 5, 6. I do. So I'm going to say OK. I want 4/12. Okay, so we've got 12 bits here. Any 4 will do. 1, 2, 3, 4. It's telling me that 4/12 is the same as 1/3. That means that if we group together 4 of these 12ths here, that's a 2nd third, and 4 of these 12ths here would be the 3rd third. So we're looking at equivalent fractions. Let's do the next one. Square, they want a 9th. Let's try something different. Let's try a hexagon, they want 1/12. Hexagon has got 6 corners, so I'm going to put a division in each vertex, each of those corners, which means I'll have 6 divisions when I've done that, and I do. I have 1, 2, 3 on the side, 1, 2, 3 on that half, and I can just divide each 6th in half, which gives me 12 pieces. They are 12ths. If they were all slightly different size, they would not be 12ths. They'd be something else. They'd all be something different else, all mixed up fraction sizes. You might have an 11th, a 12th. One of them might be correct. But these two here, this would be bigger than a 12th, and this would be smaller, so it's not balanced up. They must be the same size, and there must be 12 of them. I think I'm correct, so let's just check the sizes. It says I am, and I want 1/12, so that amount there is my 1/12. Checking it, it's all good. Let's go for a rectangle. It wants 6 sixes, which is 1. I'm going to divide this way, and I'm going to divide thirds that way. So I have my thirds going down in column, 3 bits according to these divisions here, 1, 2, 3, and then I've basically chopped each third in half with this horizontal line here. Let's take it out. They're thirds, 1, 2, 3 even sized pieces. Put another cut halfway across all the thirds, and I've made 6ths. Okay, it agrees that they're sixths. 1, 2, 3, 4, 5, 6 sixths is equivalent to 1 whole. All of them, 6 out of 6, brings me to my whole piece. Okay, let's try triangle, 2/3. So I'm going to chop my triangle into 3 even sized bits. I'm going to go straight into the corners, the vertices, and each of those should be the same size, and it wants 2 bits out of 3. Alright, which is that part of the fraction. Back to rectangles, I want to do more. I want 1/6 now. I'm going to not use those, I'll use this side. And 1, 2, they're not the same size. Make them each 3 big. So that spacing does create the same cuts, but I've only got 4 of them. I need to make 6 equal cuts. If I half those 4s, so in other words, if I put a line in half, I'm going to get 8 pieces, which gives me 8ths, not 6. So that ain't good to me. So what I might need to do is work with the fact that I've got 6 divisions here. So I'm going to ditch these lines, and if you notice up this scale here, I've got 6 divisions, 1, 2, 3, 4, 5, 6. So I like that. That helps me to make 6 equal size pieces. And I have to use every single one of them to get my slithers of 6. So one of these is 1/6. If I look across the top, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 bits. So what could I have done there? I could have cut every second one and I still would have got 6ths. So let's do that as well. So instead of long skinny ones that way, I can also set them up this way. Which I could have done the first time, but I was a bit lost. Now this here should give me 6 equal size bits if I continue with this spacing. 1, 2, 3, 4, 5, 6. Perfect. So that would do. They are actually the same size as each of those ones was before, those long skinny slithers. This area, or this amount, is the same as the area across there, all the way across when I made my 6th this way, horizontally. I'm going to be clever. I'm going to get rid of the middle ones. No, I won't. Put it back. Put it back. Accept it. Yep, and I just want one piece. So here we have 1 out of 6 of the amount towards 6. So 1 out of 6 shaded black. Check. Correct. Another shape. Let's go for our square. It wants 3 out of 3. So I'm going to select thirds. That will do. They are evenly sized slithers, and there's 3 of them. 3 out of 3 means all of them count, so 3/3 is the same as 1 whole. Let's just check that. Correct. And circle. It wants a half. This one's really pretty easy. We'll put one line there. No, we won't. We'll put it here. It needs to be sufficiently far away. So we've broken it up into 2, and we colour one in 1 out of 2 parts. Okay, I think we've done this one, so I think that'll do us.